Not this time. Okay. What we're doing is graphing this input, say it. Then we input, say it. We made a point that, yes, you want to plug in 0, -1, and 1, but these numbers, because this multiplier is so large, doesn't really show that asymptotic behavior. So we kept going. And then what we figured out is these graphs are identical. And why is that? Because the equations are. Watch. Okay, what did I say? Good foilers, what? We're not foiling. What's he talking about? This guy's nuts. He is, but not for this reason. You check that. Wait, is that an equivalent form to the left? What are you supposed to do with these exponents? If I had 2 to this power times 2 to that power, what are you supposed to do with them? Add them. With my ABers, I did a 10-minute refresher on exponent rules. How do you get a negative exponent? How do you get, what does a negative exponent do? Flip. How do you get a 0 exponent? Why is that equal to 1? I think I did that with you, right? What's x cubed over x cubed? What is that equal to? What is that equal to? 1. It's something over. Are you paying attention back there? Looks like you're doing a lot of rubbernecking. Okay. And then what's 3 minus 3? What's 3 minus 3, everyone? What is going on here? What's going on here is these two are equal. You just did them two different ways. You know the subtraction rule, right? You take the numerators minus the denominator just to see how many x's are left over where. All right, so that's why the 0 exponent rule exists. But anyway, so I just kind of going over those rules. Hey, what's 2 to the third, by the way? 8. That's why these are identical. Okay, so then what you come to find out is 3 left actually equals, in an exponential sense, a vertical stretch or a vertical dilation by 8. They're equivalent scenarios here. It's strange. Got to be careful. It's because the base is 2, and got to consider that. So strange, right? Knowing your transformations. Well, by golly, I bet something like that's going to happen on this one. What would you plug in first? 0 is correct. Way better than fourth hour. They're just bums. Didn't even say anything. When I would ask them, 4 to the 0 over 2 is 1. What would I plug in next? 1? Nah. 2. Actually, 1's not bad, though. Because what's 1/2? What's 4 to the 1/2? 2. All right, so it's square root. But plug in 2, because 2 over 2 is 1. 4 to the first is 4. What's the matter? Plug in -2. 4 to the negative first is 1/4. I couldn't care less where the x-axis is. We're not going crazy on, inputting so many points that we get super large or super small y values. 2, 3, 4. Wrong. That was 2 comma, right? 2 comma 1, 2, 3, 4. And a -2 comma a fourth. That's enough to denote the behaviors. What I was missing on the other one, I guess it was that factor of 8 doesn't really show my asymptotic behavior too well. What do I plug into this one? 0. 2 to the 0 is 1. Hey, we're going to do this again. You know what? Just for giggles, I know what he did on the last one. He's trying to climb into my brain and make me understand something. When I plug in 2, because I plugged in 2 over here, do I get 4? Yes, I do. When I plug in -2, do I get 1/4? Well, 2 to the negative second is equal to 1 over 2 to the second for those that don't know their exponent rules. I do. So apparently we have equivalent functions here if the graphs end up being the same. Nice. Nice extrapolation by the two in charge here, Mrs. Cooper and Mrs. Gray. All right. So how did that happen? Well, let's go back to this and break it down. Does anyone know hammer time? They're all just looking at me. These dang kids, they wear their shirts like they know this group, and they never know one song from the group. Not one. Is this true? But the thing about the shirt's true. But is this true about the exponents? Yes? Yes. Actually, some people wear concert shirts and they do know the songs, right? Okay. Didn't you once? I caught you once. No. Yeah, you did. Didn't you have a Nirvana shirt on or something? No. Somebody in here. What's 4 to the 1/2 power? Oh, drink time. Oh, I thought you were okay. What does the 1/2 power mean? Square root. Okay. And then, oh, what's the square root of 4? Isn't it plus minus? You never have a and no, it's not. It's only plus minus when you're solving this by square rooting, because both 2 and -2 squared equal 4. So this would just be 2. But you also can never have a negative b value. So that's why those are equivalent. Okay. So yeah. So what do you know? Yeah, we got the conclusions. Okay. So look. Yeah. Oh, I didn't fill this out with the other team. So every horizontal translation of an exponential function apparently turned into a vertical dilation. Now, it depends if it's plus or minus. So I don't know if it's stretch or shrink. You have to analyze it. All right. And then whenever you have that, what is this? This actually changes the base of the situation. So it is equivalent to a change of base. So you actually change the base is what ended up happening on that one. All right, and you will get questions like this. This is worded really well. I had we're actually doing this right now in AB. They have a quiz tomorrow on this concept, rewriting things in equivalent forms. This is the best way of asking this question, I think, for the students, so that you understand how is this not the same. Well, it's that plus 2. I got to get rid of that. I got to put this in a times b to the x with no right left shift. So it's real simple. You just do this. Good foilers say it. Why does he keep saying that? Because you're a fraud, a charlatan, which then makes you a bum. If you have a 5x squared plus blah, 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 some trinomial, and you write this as a final answer. Good foilers say it. Liar! Because what's x times x? X squared. Is it 5x squared? Yes or no? Bum. Okay. No one should ever do that. And that's what I tried to impart upon my ABers since August. And I swear they just do it on purpose to get my blood boiled. All right. Anyway, hey, what's e squared? A number. Isn't it lower than 9? Why? What is e? Everyone should say it right now. 3, 2, 1, go. 2.7. What did you hear him? 4th hour. All right. So so that's my A value. I don't know what it is though. I mean, I could square it. It'd be under 9 over 4. I did guess that it was somewhere around 7. And then I think I typed it on my calculator. There it is. Hey, here's E. There's 2 spots for E. There's E here, but then there's also E caret. Delicious. So that's how you can manipulate E there. Okay, and I think I showed E on the calculator yesterday, where it was located, and we typed it. You know what this one is? Wait a minute. Oh, what am I supposed to do with these exponents? What am I supposed to do with those exponents? Multiply them. Is 1/3 times x, x over 3? Okay, what's 2 to the 1/3? What's 2 to the 1/3? Cube root of 2 to the 1st. Okay, I do want to put all the parts in there, so I'm trying to remind you of that rule. And then raised to the x, so darn tootin', yeah, it changed that base. Hey, what's a, by the way? Because it says put it in y equals a times b to the x. What number is sitting out here? 1. Some people like get crazy about that. What's a? Okay. These are things that we don't write. Oh, I gotta keep doing that. Who made that noise? Oh, you know what the transformations are on this, by the way? We should write this above. The transformations on this are y-axis reflection. So that's a y-axis reflection. And then 1 which direction? I got it. Right. So I get nervous people misidentifying what if this was a question, just what are the transformations? Are you okay over there? Remember the Samulus alarm clock at the end of the year in the Samulus store? It's also a put to sleep device, right? This is the sleep time. Okay, but anyway, is this true? Yeah, it is. I add those exponents, I end up with this. And then I end up with 3, and then what's 3 to the negative first? So then I'm doing a couple rules. What's 3 to the negative first? 1/3. I feel like I put 1/9 last hour. Hopefully I didn't. So now it's in a times b raised to the x form. Okay, so definitely a big change on that. Hey, then why is that a y-axis reflection? Because 3 raised to a power is supposed to be an increasing graph. But when I flip it over the y-axis, then it's decreasing like this. Oh no. I had an idea to tell my last hour. Remind me when I graph this one to talk about increasing, decreasing as opposed to growth decay. Remember, I was kind of like, I hate this, what the AP does and kind of confuses. And then what I realize is those are 2 different things. They're not related. You got it? So remind me that I say that. I forgot the other hour. Okay, then this last one, and I'll tell you have choices after this. I'll tell you when we're graphing, what am I supposed to do? Basically, I'm going to tell you do whatever you want. But what you could do, if I had to graph this, you could change it and then graph the new looking function, knowing it's equivalent, or you could leave it alone. Input, say it. Doesn't really affect input output. So you're up to do whatever you want. And then what's 3 to the negative seconds? 1/9. So now I'm kind of using the rules liberally. Is that true? Yeah, because I'd multiply those exponents and I'd be back to 3 to the negative second times x. And then, yes, this is true because I would add these exponents. So reverting backwards, that's what good FOILers, good factors means. I write my answer and I make sure, does that make sense? Does that exercise the exponent rule correctly? Because now, would I want to change this one? Heck no, no way. I don't want to change this to y equals a times b to the x. That's going to be a lot of extra work. I don't even really know enough about it to square it, and understand what that decimal is. No, just input, say it. I can't get the first value. What am I going to plug in for x first? Come on, 5th hour. Tell me the number that I put right here. -2. Good. You're better than 4th. -2 plus 2. Tell them. Okay. By the way, do this. You really got to think of it this way because -2 plus 2 is 0. E to the 0 is 1, but then it's negative, right? -1 plus 5 is 4. Now, why do we have these? And this is good by the other 2 teachers. This is awesome. This gives you the choice if you want to go crazy on your chart and get really, really large y values. You should know what's going to happen with this, though. I get -2. Oh, wait a minute. I know that this is y equals 5 as a horizontal asymptote. 4, 3, 2, 1, 0. Then here's where the x-axis is, because I also know that this is going to be upside down. So now I have all this room to get really large negative y values. So I'm just trying to explain why they gave you the coordinate planes the way they did. So you have the power to move around stuff. Do we really need it? Probably not. So it's okay, though. We're not judging. -1 and -3, right around there. So the only thing you could really do on this is -1 plus 2 is 1. E to the first negative. So this is negative e plus 5. And then I could think about it for a little bit. -2.78 plus 5. That's approximately 2.2. So I got -2, 1, 2, 3, 4. -1, like 2.2-ish, because -2.718 plus 5 is right around there, right? Not gonna really know exactly where that's pinpointed anyway. Then this becomes a problem. -3 plus 2 is -1. So this is -1 over e plus 5 which is a really small negative decimal plus 5, which is 4 point something, right? You know, it's negative. It's almost like that's almost like negative a half, or negative a third is even closer. So this is close to 4 2/3. So negative or 4 2/3, somewhere around there. That's enough. If I wanted to find the y-intercept, that's 0, comma. That's weird. It'd be -1 over e squared plus 5, which is even smaller. But so is that right? Did I do that right? I feel like I did something wrong there. 0. No, I did do something wrong. I'm a moron. I was going in I did. It's actually negative e squared plus 5, not 1 over. Okay, 0 plus 2 is 2. So it's e squared with a negative on it. And then I just did the e squared. Am I boring people? That's fine. E squared is that. So negative 7.38 plus that is negative 2.38, somewhere down there. So if I had a calculator, I could actually find the y-intercept. Just giving you some extra information. I'm not doing all this stuff. Limits as x goes to negative infinity, y goes to 5. Positive infinity, y goes to negative infinity. Asymptote is y equals 5, so on and so on and so forth. I really don't think it helps us in its extra work to change that. I think we could just input output. We should have an idea what's happening though. Compared to 2 to the x, this is a y-axis reflection and 1 right. But I don't need any of that. What do I plug in first for x? What do I plug in? 1. 1 minus 1, 0. 2 to the 0 is 1. You know what? I'm just going right here. So I'm not going crazy. 1 comma 1. Not that it's crazy to have this grid. Not saying that. Not being judgmental. I never am that. What are you laughing at? 1 minus 0 is 1. 2 to the first is 2. 1 minus 2 is negative 1. 2 to the negative first is a half. That's enough. That's enough. It's enough. 2 comma half. Oh, hey, and I do have the y-intercept. 0. Oh, I know if I keep plugging in these will keep taking off. So there's the flip over the y-axis. It's decreasing. Oh, you bums. What did I just tell you? What did I tell you to tell me over here? Remember this over here? You remember this? All right. Is this graph increasing or decreasing? Which one is it? It's decreasing. That doesn't change. What's our debt doing nationally under this current administration? What is it doing? Growing. Actually, every administration. I don't know why we don't care. Was it here in class that I talked about this? The national debt, then I guess our solution will be we'll just bomb the people that we owe the money so we don't have to owe it anymore. Anyway, so what's this? Is this growth or decay? Take a guess. 3, 2, 1, go. It's actually growth. That's the thing. These are different. And that's where my mind was like, I had problems with this as a teacher, like how to explain this to you. Then I had like an epiphany. This is what they're saying. They're mutually exclusive. They're different. Okay. So don't, worry about that. Okay. So that's what the AP people say. This is actually still considered growth. Crazy to me, but now I kind of get it. Now, this really would not work to change this because, then if I did, this would be 3 squared and then 3 to the negative 2x. This is going to flip. Then this is going to be a multiplier in front, and then I still have to input, say it. I'm just going to go input, output. What number am I going to plug in first in the original? What number? Not 0. 1. I want the 0 exponent. That's the point that's closest to it's where the 0, 1 point ends up. So it shows your reflection. So you know what this means? There's a 1 right hiding in there. So if I were to think about this, what are my reflections? I take out a negative 2. Oh, and then it's x minus 1. There's the 1 right. By the way, if I did do that, you might have to do this. I'm not doing this to bore you. I'm doing this because there might be questions that say, hey, as it stands, what are these transformations? Well, then you know what the transformations are? Let's zoom in on this. What happens to 3 to the x? What is that? What kind of reflection is that, x or y? Y. What kind of dilation is this, horizontal or vertical? Horizontal. And is it a stretch or a shrink horizontally? Shrink. So what is the factor, 2 or 1/2? 1/2 inverse, right? And then 1 right and 4 up. So 4 up should be good. Let's just go ahead and see what we get when we plug in 1 though. 1, 2 minus 2, 0, 3 to the 0 is 1, 4 minus 1 is 3. So I'm just going to go here. I don't care. I couldn't. Anyone? Okay, base of 3. So 0 and 2. 2 times 2 is 0. 2, 3 squared is 9. 4 minus 9 is -5. This was kind of blowing my mind. I'm like, wait a minute. Last hour, I kind of questioned this. This seems awfully steep right away, except what did I just say that 2 was? A horizontal what? A horizontal what? Shrink. So it takes the graph and pushes it towards the y-axis. That makes it look skinnier. Okay, and that's why then I was like, oh, okay. That makes sense. And then 2 times 2 is 4. So this is 2 minus 4, which is -2. This is 4 minus 3 to the -2nd, which is 4 minus 1/9. So that's 3 8/9. So that proves my y equals 4. Is this the last one? Did I collect your stuff to stamp? Guess what? We'll be stamping then. And then you could, sorry, you don't have all those things listed like that. You just fill in the blanks like yesterday. So you're gonna have to write out all that stuff. Limit statements, horizontal, y-intercept, range, domain. It's all pretty easy. Okay.